So here's 8.47. Draw the Lewis dot structures for each of the following. The first one we have is SiH. Let's go through the steps. Add the electrons, valence electrons. Silicon in group 14, so it has 4 valence electrons right here. Hydrogen has 1 valence electron, and there are 4 of them, so that's 1 times 4, or 8, total of 8 valence electrons. Put the least electron negative in the middle, and remember it can never be hydrogen. Never hydrogen in the middle of anything. Hydrogen can never have more than 1 bond. So put your silicon in the middle, bond your hydrogens around it, and look at that. We have 2, 4, 6, 8 around the central atom, and each hydrogen has a duet of electrons, and so we're done with letter A. Bond around, that's what that means. Let's see, letter B right here, CO. So in CO we have carbon, which is in group 14, so that's got 4 valence electrons. And then we have oxygen, which is in group 16, and that's got 6 valence electrons, so a total of 10. No way you can have a central atom here, so you just bond carbon to oxygen. And if you did that, that used up 2 electrons, so you have 8 left. But then you see you got a problem if you want 2, 4, 6, 8, because you would have an absence of electrons there on oxygen. So if you're stuck, then you got to try a double bond. So use 2 more up. Now we're down to 6 remaining. And if you went 2, 4, 6, you'd still have an electron deficient atom right here. So we'll try one more bond. Triple bond right here, minus 2 more. Now we're down to 4 left. And if you did 1, 2, 3, 4, now we've got 8 electrons around here, 8 electrons around here, and we have a carbon monoxide with a triple bond and 8 electrons around each one of the species. Letter C. This one is SF2. So then we've got sulfur, 6 electrons on the periodic table right here, group 16. And then fluorine, group 17, so 7 electrons in the periodic table, so 7. 14 plus 6 is 20. Put sulfur in the middle, bond the fluorines around it. 2, 4, 20 minus 4, 16 remaining. 2, 4, 6, 8, 10, 12, 14, 16. Oh yeah, all the electrons went around the central atom that were extras after we completed the octets around here. So now we've got our sulfur difluoride right here. Completed octets for each one of the atoms. All right, letter E. Now we have an ion. Oh, I'm sorry, we're up to, let's see, that was C. We're up to D. Letter D is H2SO4, and it gives us a hint too. It tells us H is bonded to the O. So add them up here, 2 for hydrogen, there's 2 of them. Sulfur is in group 16, so it's got 6. And then oxygen is in the same group, so that's got 6 as well, and there's 4 of those. 6 times 4 is 24, plus 6 more is 30, so we have 32 valence electrons. Whoops, I don't know why I put a 2 here. 2 times 1, because there's 1 in each hydrogen. So that's a total of 32 valence electrons. Put the least electronegative atom in the middle that's not hydrogen, so that would be sulfur, because sulfur's down here, oxygen's up here, it's more electronegative, so put that in the middle. And then let's bond the oxygens around it. And then it says in the hint right here that hydrogen is bonded to oxygen. So we've got to stick the hydrogens off of a couple of oxygens. Just pick the ones that you want. It doesn't really matter. You could put them off of these 2 as well, or 1 off of here and 1 off of here. Doesn't really matter. But now that we've put the bonds around, we've got 2, 4, 6, 8, 10, 12. 12 electrons so far. So 32 minus 12 gives us 20 electrons remaining. If we complete the octets here, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And we've used them all up, and now we've got 0 electrons remaining, and everything's got an octet, and we've just drawn sulfuric acid. Now we're on to letter E, and we've got ClO2 minus. Chlorine has got 7 electrons in its valence shell, and then oxygen, of course, in group 16, so it's got 6, and there's 2 of them. And then remember, when it's an ion, if it's negative, you've got to add 1 more electron to it. So 6 times 2 is 12, plus 7 is plus 8 here total, that gives us 20. So 19 plus 1 more is 20. So 20 electrons, put the least electronegative atom in the middle, so chlorine's going to have to go in the middle because that's just a little bit less electronegative than oxygen. If you wrote it on your periodic table, chlorine's like 3.0, oxygen's like 3.5. So a little bit less electronegative, and then bond the oxygens around it. All right, let's see, we've got 2 electrons, 4 electrons gone, 16 remaining, and then if we put these 16 around them, 2, 4, 6, 8, 10, 12, 14, 16, we'd use them all up, and everything would have an octet of electrons. Put it in brackets and put a little -1 out there because remember it's an ion. And the last one, letter F, NH2OH. Now remember, lots of times they write it kind of in order of what you're going to bond it in, and also remember that hydrogen can never ever go in the middle. So we might be looking at a nitrogen connected to an oxygen with a couple of hydrogens off it, and then an oxygen connected to a hydrogen as well. Even though it's written in this way, don't stick the hydrogen in the middle. Let's add them up first though. Nitrogen is 5 because it's in group 15. If you look on here, nitrogen, group 15. And then hydrogen, there's 2 hydrogens, so that's plus 1 each. And then oxygen is 6 plus 1 more for this hydrogen right here. So we've got 7, 8, 9, 14 total valence electrons. The nitrogen right here, let's connect it to the oxygen, and then let's do what it says right here. Let's put the hydrogens off of here, because it says NH2, and they must say that on purpose because the nitrogen must be connected to the hydrogens. And then we have an OH, so let's put the other H off of the oxygen right here. Let's add those bonds up. 2, 4, 6, 8. 14 minus 8 means we got 6 remaining. 6 remaining electrons goes 1, 2, 3, 4, 5, 6, and we have an octet here, and we've got duets around each one of the hydrogens.